for detection of quadrilateral document region from digital photographies. Nowadays, everyone has a cell phone, and cell phone camera is getting better and better. So obviously, we can use cell phone camera to capture various documents, not only just paper documents, but even screen presentation like this one, and whiteboard and so on. But we also want to do some enhancement for this type of capture documents. So the problem in this presentation is we try to locate the quadrilateral document region. Because if we identify locate those regions, it's very useful because we can do rectification and we can do cropping and so on. So this is the problem of this work. So now here is our approach. Because we the document, that type of document could have all kind of arbitrary contents. So it's very difficult to make any assumption about the contents. So basically, our approach is content independence. Being content independence, we have to start with edge detection and line detection. And from line detection, from lines we detect that we can create quadrilateral candidates for each quadrilateral candidate, and then we can construct 4 features. So you can imagine, because there's many lines we detect, so every 4 lines will make a quadrilateral candidate. So there could be a huge number of this kind of quadrilaterals. So it will be desirable to do some reduction in terms of search space in the number of candidate quadrilaterals. So in the paper, we derived some shape-based measure, try to eliminate some candidate. So and after we make some eliminations, so then we have to do some exhaustive search, basically look at every candidate quadrilaterals. And then we need to do ranking. Because in this case, it's not we want to detect all the quadrilateral or rectangles. We want to detect only one. And hopefully by the rankings, the one corresponding to the document, real document region will be top rank. That's our goal. So in terms of ranking, we basically use learning to rank. So in this particular work, I mean, basically we're also limited to a linear ranking function. That means for 4 features, we only need to learn 4 ways. So here's a little bit more detail in terms of features and learnings. As I mentioned previously, we have 4 features. And in particular, those features are based on completeness of 4 corners and the completeness of the 4 sides, and also the area of quadrilateral, and also the content lines, because sometimes we do able to detect some lines in the content region. So regarding the ranking, learning to rank, there are a couple issues we need to solve. First, because learning to rank is a supervised learning, so we do need to have a ground truth, but ground truth is not very difficult because you can humanly click on 4 corners of the quadrilateral. That will make ground truth. But more than that, we need to have some measures to able to rank all the candidate quadrilaterals. Then also we need error measure to measure the final result. So in terms of ranking, we have 2 learning algorithms. One is a ranking SVM. The second one is list net. So here's the final experimental result. We have 303 images, some 175 used for training and 128 for testing. And based on our measure, we make a comparison between the 2 learning methods, and our results indicate that the list net is performing much significantly better than the ranking SVM. We also compare with the existing method by Zhang and He, and our methods perform significantly better. Thank you.